Okay, so we're up to 4.4 Cauchy integral formula, and yeah, just remember here is a circle. Whoops, there's a circle. There's an open disk centered at A, radius R, and then the closed disk. So it includes, so the union of C and D here is D bar. Okay, and they usually things are oriented going around counterclockwise when they talk about it. And so Cauchy's theorem is if F is holomorphic in an open set containing the disk, the closed disk, then you can actually kind of calculate this integral over here with FW. So F of W is equal to 1 over 2 pi I. The integral over that path, well, closed path, and then F of Z over Z minus W. So the big trick with this is, kind of turning some integral into something that looks like this. So, okay, we have, let's see, where are we going here? All right. So we have for our section 4.4, we're saying that we could write F of W equal 1 over 2 pi I integral over a circle of centered at W with radius R, and then F of Z over Z minus W dz. So now notice what's happening here. So you've got some G, and here's your disk D bar, and what we know is that F prime of Z exists everywhere in there. And so then when I introduce F of Z over Z minus W, it's holomorphic in the disk that we have there minus that one point W. Okay, so that's the idea, is that that F of Z we would get for this integral, if we didn't divide by the Z minus W, we would just get 0. Okay, that's one thing we know already. And often you can then rewrite this a little bit and say, oh, okay, well actually I'm interested in the integral, so I'm going to do C W R, and then my F of Z over Z minus W, F of Z over Z minus W dz, and that's equal to, multiplying by the 2 pi I on both sides, 2 pi I F of W. So you see now it looks much more like a way to calculate an integral. Alright, so they give an example. We'll have to jump down a little bit to find it. Example 4.26. So I'm going to write it down and then switch over to there. I know you don't trust me, but so we're doing the integral of C centered at I, radius 1, of dz over z squared plus 1. Okay, so that's what we're going to work on. And let's see, where am I? Oh yeah, right here. So now what we notice is Well, this thing factors, right? So this is the integral, I'm just going to call it C for now, dz, and z squared plus 1 factors into z plus I and z minus I. Well, isn't that convenient? See, we've got our z minus I, which is going to function as that z minus w because we're centered at I. And then we just need to figure out what our f of z is. If we do that, well, this is equal to that integral over c of 1 over z plus I and then over z minus I dz. And there we've done it. We've written it this way. So here is our function f, and so that says this is equal to 2 pi I 1 over I plus I, because that's our f of I. And so that's 2I, and so I guess we get pi. Okay, so that was a pretty straightforward example, but that's the idea, is that all of a sudden, you know, I've got this integral that looks like it might be hard. I don't know if it, you know, it looks like, well, if I was going to do it, I'd probably go to that partial fractions thing, but I don't need to, it turns out, in this case, because of the Cauchy integral formula. Okay, so we'll stop that video right there.